For this lesson in ratio problems, we're going to take a ratio right here. Now, a ratio problem stems from when we get a ratio or proportion, okay? And a proportion is when one ratio is equivalent to another. So if we were to reduce 15/20ths, we would get 3/4. So we know these are equivalent fractions. And so a way to test that is to get the cross product. And a cross product is when we multiply the denominator of one side of the equation with the numerator of the other. So like the cross product here would be 4 times 15, which would be 60. And the cross product between of 20 and 3 would be 60. So when you have a proportion, two equivalent fractions equal to each other, their cross products are going to be equal. And so what we can do is use that law or that phenomenon that happens every time with proportions and use it to solve a ratio problem. In a ratio problem, usually you see what you'll have is a fraction equals a fraction, and usually one variable is missing, or one of the four pieces of information is missing. So we use the cross product to solve it. And so we take it in steps. In order to solve that, I don't know if you can read it. It's kind of small. We have 4 over m equals 21 over 5. So we have that. Now we're going to set the cross products equal to each other. So I'm going to say 21 times m is 21m. 4 times 5 is 20. So I did this times this equals this times this. So when we do that, in order to get m by itself, we divide both sides by 21. And so m is 20 over 21. Now we couldn't have done that just by going, oh, okay, 4 times what equals 21, multiply. That would have been really tricky. So that's why we do it this way. And we show these steps. Do not skip these steps. All of proportion problems should always take no less than 2 steps. So you set it up, set the cross products equal to each other, divide, and get the answer. So see how I've got 3 lines stating the problem, doing the calculations, and the answer. Okay, so we always need to have to show our work because you're going to use this a lot later, and so please show your work. Example 2, we're going to put it into a story problem. The ratio of pigs to goats in the barnyard was 7:5. If there were 91 pigs, how many goats were there? Now, when you read a story problem and you see that you've got 3 pieces of information and you're looking for a 4th, it's usually a red flag that you're going to have a proportion problem. So, and they're very simple to solve once you know how to do it. So it says the ratio of pigs to goats. So I'm going to just do this. Pigs to goats is 7:5. Okay, so that way I know pigs are always on top, goats are on the bottom. 7:5 equals, and there are 91 pigs. So 91 goes up in the numerator because pigs were on top. And how many goats were there? I'm just going to write G. We don't know. So I'm going to use the variable for G. And now we've stated our problem. The next line would be to find the cross products. 5 times 91 equals 7G. Now, I happen to know that 5 times 91 is 455, but if I didn't know that, I would just do it off to the side. And the reason I know that is I'm peeking in the book. So 5 times 91 is 455 equals 7G. And then we divide both sides by 7. And again, I am looking in the book and they did this for us. 455 divided by 7 is 65. So G equals 65. And so you always take the answer, and actually G equals 65. This is a story problem, so it would be good to actually label it 65 goats. Okay. And then let's look. Pigs to goats, for every 7 pigs, there were 5 goats. So if there are 91 pigs, does 65 kind of make sense? Yes, it's got to be less than 91. And so I'm happy with that answer. Example 3. In the same barnyard, the ratio of chickens to ducks chickens to ducks is 9 to 4. And there were 108 chickens. So where does 108 go? Up on top here. And we go ahead and do that. The book flipped them over. I was curious about that. They did chickens, so they put chickens on the bottom. Anyway, I guess they wanted it bottom heavy. So what we get now is 9D equals 108 times 4. Now 108 times 4, they didn't do that for me. What they did was this. I'm going to show you a trick. They did not do 108. They left it like this. Okay? And then, instead of calculating that, they're like, let's divide that by 9. Here's why we want to do this. We can simplify this fraction here and multiply it by 4, saving us the trouble of multiplying 108 times 4. So we end up D equals 108 divided by 9 happens to be 12. 12 times 4 is 48. So there were 48 ducks if there were 108 chickens. And so what you want to think too is 108 chickens. Well, there were more than double the number of chickens to ducks. So that makes sense. If we had 108, then we would have 48. The ratio of neophytes to masters at the tryout is 7 to 2. So neophytes to masters, is 7 to 2. If we have 714 neophytes, how many masters? Now, as you can tell, our final answer better be well below 714 because 2 is like less than a third of 7. So this should be less than a third of 714. So that just gives us a help with making sure we have appropriate answers. So now we get the cross product. 7m equals 2 times 714. I'm going to leave it like that and see if we can divide this better. So now we get m equals, well, I know that 7 goes into 714, goes in there 102 times. So 102 times 2 is 204 masters. Now, like we said, is that should be well under 714. So yes, we are happy with that. And letter B, the crowd in Belgrade town square was made up of Croats and Serbs in the ratio of 5 to 9. There were 18,000 Serbs, so that goes down here. And we're looking for how many Croats there are. So let's see, are there going to be more than 18,000 or less? Okay, there should be less. Almost kind of close to half as many. So let's go ahead and set up with the cross product like that. And then we can divide by 9 instead of multiplying that through. And that's nice because 9 times 200 equals 1800. So now we have 5 times 200, which is 1,000. Oh, sorry, this actually was a 0. So there's another 0 there. So yeah, I left a 0 out. So it's actually 5 times 2,000. So 5 times 2,000 is 10,000 Croats. And there we go.